This is an instructional video on multiplying exponents. When multiplying exponents, it is important that you have the same base number. If you do not have the same base number, you cannot multiply the problem. A typical problem consists of a base number, in this case 4, and an exponent, 2. One method of solving the problem is to write it out long ways. While still keeping the base number the same. A shortcut would be to add the exponents. Again, keeping the base number the same. Last piece of information is to multiply the coefficients. And we'll talk about what all of that means here during the examples. For our first problem, we're going to do 8 to the 7th power times 8 to the 3rd power. So again, one method is to write it out long ways. 8 to the 7th can be represented by the number 8 written 7 times. Then we can do the same thing with 8 to the 3rd. The base number 8 written 3 times because that's the exponent. And then I can count the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 8s in this problem, meaning my answer is 8 to the 10th power. The shortcut method had us taking that problem and then adding the two exponents together. So we would add 7 plus 3, which is 10. Keeping the base number the same, 8, adding our exponents gets us the same answer, 8 to the 10th power. For our next problem, we're going to do 3 to the 4th power times 3 to the 5th power. Again, we can write it out long ways using that base number 3 and using that 4 times. And then for the second part, using the base number 3 and writing it out 5 times. We count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so our answer becomes 3 to the 9th power. Again, the shortcut method had us adding the exponents together. 4 plus 5 is going to give us 9. Keep the base number the same, 3, and your exponent 9. For problem number 3, we're going to do 5 to the 8th power times 5 to the 5th power. Breaking it down, we're going to do 5 8 times. And then for the second part, we're going to do 5 5 times. We count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Keeping the base number, we get 5 to the 13th power. Our shortcut method again has us adding the exponents together. So 8 plus 5 is 13. Keeping the base number 5 to the 13th power. This method can also be used in variables. For example, x to the 4th power times x squared. I can break it apart and write the base number x 4 times, and then again the base number x 2 times. We count them, 1, 2, 3, 4, 5, 6. Keeping the base number x the same with 6 total becomes our exponent. The shortcut method still applies as well. X to the 4th times x squared. We can add the exponents together. 4 plus 2 is 6. Keeping the base number x with our exponent 6. All right, we're going to move into a little bit more challenge problem. 3x times 5x to the 8th power. Parentheses are another way of representing multiplication. We can still break this problem down. I have 3 and x. Anytime there's not an exponent here, as in this problem, it's an understood 1, meaning I only have to write 1x when we break it down. For the other problem, we have 5 and then x to the 8th, so I'm going to write it out 8 times. Count up the variables, the base numbers, and we get 9, x to the 9th power. It's important to note that the base number is the number with the exponent. 3 and 5 are called coefficients. Coefficients are just regular numbers. We don't treat them any differently. So since the problem is multiplication, we can multiply. 3 times 5 is going to give us 15. So 15x to the 9th power. If you want to use the shortcut method, it can still apply. Remember, we put that 1 in the problem because when there is not an exponent written there, it is an understood 1. So we can still add the exponents. 1 plus 8 is 9. So we can still get our x to the 9th power. And again, multiplying the coefficients. 3 times 5 is 15. 15x to the 9th. Next problem, we're going to do 2g to the 6th power times 7g to the 6th power. I again am going to show you both methods. We're going to break it down. 2 and then g 6 times. And 7 and g 6 times. We can count up the base numbers, the g's, and we get g to the 12th power. Taking our coefficients, the regular numbers, and multiplying them, 2 times 7 is 14. 14g to the 12th power. Using our shortcut method, again, it still works. We're going to add 6 plus 6 to equal 12. Keeping that base number g the same, g to the 12th. We multiply 2 times 7 to get 14. 14 g to the 12th. Here's our big challenge problem. 3b squared d to the 4th f times 6b to the 4th d squared f to the 3rd. I'm still going to show you both methods, writing it out the long way and the shortcut. So for the first one, the shortcut, I have 3b squared, so there's 2 b's, d to the 4th, so 4 of those, and then f, there's no exponent, so I know that means there's only 1. For the second part of the problem, I have 6, b to the 4th, so 1, 2, 3, 4 of those, d squared, so 2 d's, and f to the 3rd, so 3 of those. When we count the base numbers, we have to count the ones that match. So there are 1, 2, 3, 4, 5, 6 b's, so b to the 6th power. Then I can count the d's. 1, 2, 3, 4, 5, 6. There are 6 d's, so d to the 6th power. And then we have 1, 2, 3, 4 f's, f to the 4th power. Again, we take our coefficients 3 and 6 and multiply them. 3 times 6 is 18. 18, b to the 6th, d to the 6th, f to the 4th. If you wanted to use the shortcut method, it would still work. We would add up our exponents with the base numbers that match. So b squared and b to the 4th. 2 plus 4 is 6. That's where b to the 6th came from. We could add up the d's, d to the 4th and d squared, which is 6. So again, d to the 6th power. And then f. Remember, here there is no exponent written, and so we know that that is a 1. 1 plus 3 equals 4. F to the 4th power. Multiplying the coefficients, 3 times 6 gives us 18. 18, b to the 6th, d to the 6th, f to the 4th. Okay, another challenge type problem, m to the 3rd times m to the 0. I can break it down, m to the 3rd, 1, 2, and 3. M to the 0 doesn't have to be written out because there's 0 m's. And so when we add them up, we get 1, 2, and 3, m to the 3rd power. The shortcut still applies even if the exponent is a 0. We add them together. 3 plus 0 is 3 and get m to the 3rd power. For our next problem, we're going to do 3m to the 5th with n squared times 8mn to the 3rd. Again, I am going to show you both methods. We can break it down. The coefficient 3, 5 m's, and 2 n's. For the second part, we have our coefficient 8, and m, remember there's nothing written there, so that is an understood 1 for our exponent, and then n to the 3rd. When we count the base numbers, we count the ones that match. So we're going to put the m's together. 1, 2, 3, 4, 5, 6 m to the 6th power. And then we're going to put the n's together. 1, 2, 3, 4, 5. N to the 5th. And again, keeping our coefficients as just regular numbers, we multiply 3 times 18, which is 24. 24, m to the 6th, n to the 5th. Keeping with our shortcut, we add the exponents where the variables are the same, our base numbers being the same. So m to the 5th and m to the 1st. 5 plus 1 is 6, meaning m to the 6th power. With our n base numbers, 2 plus 3 is 5, giving us n to the 5th. And our coefficients being multiplied, 3 times 8, which is 24, giving us the coefficient 24. 24, m to the 6th, n to the 5th.